Hey there, and welcome. Have you ever looked at something like a pizza or a car wheel or even a donut and just wondered about the perfect math that's kinda hiding in plain sight? Well, today we're gonna crack the code of one of geometry's most important shapes, the circle. Let's dive in.
But first, let's kick things off with a little puzzle. So picture a donut. How in the world would you figure out the area of just the delicious, sugary part without counting the empty hole in the middle? It sounds a little tricky, right? But it's a classic geometry problem.
And the answer, maybe you guessed it, is all about understanding the simple, perfect rules of the circle. It's the key that's gonna unlock the solution to our donut problem, and honestly, a whole lot more.
Okay, so before we can start measuring anything, we need to learn the secret code of the circle. Its most basic parts. Let's break down what makes every single circle tick.
First up, we have the radius, and we usually just call it r. You should think of this as the most important building block. It's just a straight line that goes from the dead center of the circle right out to its edge. Pretty much every calculation we're going to do today starts right here.
Next, we've got the diameter, or d. Now, this is the full distance straight across the circle, but here's the catch. It has to go right through that center point. It's kind of like drawing a line that slices the circle into two perfect halves. And the relationship between these two, it's awesome and super simple. The diameter is always exactly 2 times the radius. And that means the radius is always just half of the diameter. So the big takeaway is this. If you know one of them, you automatically know the other one. It's a 2-for-1 deal.
And now for the magic ingredient, the number pi. You'll see it written with this Greek letter, pi. Pi is this really cool constant number that's roughly 3.14, or you can think of it as the fraction 22 divided by 7. But here's the amazing part. Pi is the key that unlocks the calculations for any circle in the entire universe, no matter how big or small. All right, now that we have our basic parts, let's make our first real measurement. How do we figure out the total distance around the outside of a circle? Well, that's called the circumference. So there are 2 really simple formulas for this. You can either multiply pi by the diameter, or you can multiply 2 times pi times the radius. And since the diameter is just twice the radius anyway, both of these formulas are going to give you the exact same answer. Pick whichever one's easier. You know, if you ever have trouble remembering what circumference is, just picture a pizza. The circumference is just the total length of that yummy, crunchy crust that goes all the way around the edge. Okay, so we've handled the crust. Now let's move on to the main event. How much space is actually inside the circle? In our pizza world, this is all the good stuff. The cheese, the sauce, the toppings, the total area of the pizza. The formula for the area of a circle is just pi times the radius squared. And don't let that little 2 scare you. Squared just means you multiply the radius by itself. So it's just pi times the radius again. This one simple formula gives you the entire space inside the circle's edge. Let's actually try it out with an example. So imagine a circle with a radius of 7 centimeters. We start with our formula. Area equals pi times r squared. Then we just plug in our numbers. We'll use 22 over 7 for pi, so the math is 22 over 7 times 7 times 7. And check this out. One of the 7s on the top cancels out with the 7 on the bottom. So we're just left with 22 times 7, which is 154. And since our radius was in centimeters, our area is in square centimeters. See? Simple as that. Okay, let's try one more. This time we've got a circular garden with a diameter of 28 meters. Now remember, our formula needs the radius, not the diameter. So our very first step is to just cut that diameter in half. 28 divided by 2 is 14 meters. Now we're ready for the formula. 22 over 7 times 14 times 14. And when we run those numbers, we get a final answer of 616 square meters. This is a perfect example of why you've always got to check if you're working with the radius or the diameter before you start plugging things in. All right, we now have all the tools we need. It's time. Let's go back to that original challenge we started with, the donut problem. How do we find the area of the space between 2 circles? Well, there's a really powerful and honestly simple idea for solving problems just like this. To find the area of any kind of border or pathway, you just have to find the area of the big outer shape and then subtract the area of the small inner shape. So the big question is, can we use this exact same logic for our donut? I mean, it's really just a path between an outer circle and an inner circle, right? Oh yeah,
You bet we can.
And the process is just 3 easy steps. First, you calculate the area of the whole big circle, just pretending the hole isn't even there. Second, you calculate the area of just that small inner circle, the hole itself. And for the grand finale, you just subtract the small area from the big one.
And whatever is left over is exactly what we wanted all along, the area of just the ring. This is the formula for our donut, for a running track, for a washer, for any ring shape. It is so useful.
Whew, we have covered a lot of ground. So let's do a super quick recap of the essential formulas you'll want to have in your geometry toolkit.
Here they are, all in one spot. For the distance around the circle, the circumference, it's 2 times pi times the radius. For the space inside the circle, the area, it's pi times the radius squared. And for our donut problem, the area of a ring is just the area of the outer circle minus the area of the inner circle.
So there you have it. We've cracked the code. The next time you see a bicycle wheel, a roll of tape, or even a plate, you'll know exactly how to measure it. So the last question I'll leave you with is this. Now that you've got the tools, what other donut problems can you start spotting in the world all around you? Thanks for tuning in.